The topic is organic chemistry, specifically alkanols. Alkanols. By the end of this lesson, we'll be able to state the functional groups of alkanols, classify alkanols based on the number of hydroxyl group and based on the number of alkyl groups in each molecule. We'll be able to describe the preparation of ethanol from ethene and by fermentation. We'll be able to state the properties of ethanol, both the chemical and the physical properties. Also, we'll be able to state the uses of ethanol. Alkanols had been known for so many years because of their intoxicating effects. We simply call them alcohols. Alkanols are organic compounds that contain the hydroxyl group -OH as their functional group. Hydroxyl group is the functional group of the alkanols. They are derived from their corresponding alkanes by replacing the E ending with OL. So if we have an alkane like methane as an alkanol, we'll call it methanol. Methane is called methanol. Alkanols are also formed by replacing the hydrogen atom of the alkanes by the hydroxyl group. So if we have methane with CH4, we can change it to methanol by removing the H and replacing it with OH so that it will be CH3OH. The monohydrate alkanols have the general molecular formula CnH2n plus 1OH, or we can put it together as CnH2n plus 2O. This one does not show the functional group OH. N starts from 1, 2, 3, and so on and so forth. The general formula of the alkanols is R-OH. R represents the alkyl group, while the OH represents the hydroxyl group, which is the functional group. Naming of alkanols. We can name the alkanols by, first of all, forming the molecular formula, the structural formula, and then we use the IUPAC name by adding OH, like I have explained earlier. For instance, we have CH4O. When we put the structural formula, we have it as CH3OH, and that is methanol. Methanol. We have CH2H6O, which can be CH2H5OH, or you can put it as CH3CH2OH. That is ethanol. We now have 2 carbon atoms, so ethanol. In the third one, we now have 3rd carbon atom, that is CH3H8O, which is CH3CH2(2OH, or simply C3H7OH, which is propane 1-ol. We can also change the position by shifting the OH to the 2nd carbon atom, where we will have CH3CH2OH CH3, and that one will be propane 2-ol. We have another name, CH3C4H10O, which we can break into CH3CH2(3OH), and that is butanol, butan 1-ol. Now we have C4H10O, that we can change the position of the hydroxyl group to the 2nd carbon atom. So we have CH3, CH2, OH, then CH3 at the end. That is butan-2-ol. Butan-2-ol. So this compound, they have the same molecular formula, CH4H10O, but their names and their structure they are not the same. So like we explained in chemistry, they are isomers. Butan-1-ol and butan-2-ol, they are isomers, while propan-1-ol and propan-2-ol are isomers. Classification of alkanols. We have two main classifications of alkanols. We have classifications based on the number of hydroxyl group on the compound, while we have classification based on the number of alkyl groups in the compound. So we take, first of all, classification based on the number of hydroxyl group. Classification based on number of hydroxyl group, we can classify alkanols as monohydric alkanols, dihydric alkanols, and trihydric alkanols. Monohydric alkanols are alkanols with only one hydroxyl group. Alkanol with only one hydroxyl group are called monohydric alkanols. Example is ethanol, and the other examples I've given earlier, they are all monohydric alkanols because they only contain one hydroxyl group. Another classification is the dihydric alkanol. The dihydric alkanols contain two hydroxyl groups and per molecule. You can see this compound. We have CH2OH and CH2OH linked together by a bond. This compound is called ethane-1,2-diol. Ethane-1,2-diol. When we have more than one hydroxyl group, we put a di. So this is or tri. So this is ethane-1,2-diol. It's a dihydric alkanol. Now the trihydric alkanols are alkanols with three hydroxyl groups per molecule. That is a typical example is propane-1,2,3-triol. The trivial name or the common name is glycerol. So you can see it has 3 carbon atom and it has 3 hydroxyl group. 1, 2, 3, 3 hydroxyl group. Propane-1,2,3-triol is a trihydric alkanol. The second classification of alkanol is classification based on the number of alkyl groups per molecule. So in this one, we have classification as primary alkanols, secondary alkanol, and tertiary alkanol. When we talk about types of alkanol, probably in a question you were just asked to list the types of alkanol. Know that they are asking for classification based on the number of alkyl groups. Now we have the primary alkanols. The primary alkanols are the alkanol that contain only the alkanol that contains one hydroxyl group and only one alkyl group that is attached to 2 hydrogen atoms. Look at, this is an example of a primary alkanol. You can see the carbon that is linked to hydroxyl group attached to 2 hydrogen atoms. Sometimes the bonds may not be shown. They will just put it as CH2OH. When you have an ending like CH2OH, know that that is a primary alkanol. And this compound is 1, 2, 3. So this is propanol or propan-1-ol. Anytime we have propan-1-ol, butan-1-ol, ethanol, methanol, when the hydroxyl group is at the end, is a primary alkanol. Now we go to the secondary alkanol. In the secondary alkanol, it contains 2 alkyl groups. two alkyl groups are attached to the carbon atoms that bears the hydroxyl group. The carbon atom that bears the hydroxyl group is attached to two alkyl groups, and this is a typical example. We have the hydroxyl group here, and we have two alkyl groups. We can represent this alkyl group with only R, or we can represent it with the CH3 or CH2 like I've shown. So this compound is 1, 2, 3, 4. So this is butan 2-ol. Butan 2-ol is a secondary alkanol. Whenever we have butan 2-ol, propan 2-ol, they are, or pentan 2-ol, they are secondary alkanols. Now we go to the last type of alkanol, which is the tertiary alkanol. The tertiary alkanol contains three hydroxyl groups attached to the carbon atom that carries, three alkyl groups attached to the second carbon atoms that contains the hydroxyl group. That means there is no hydrogen attached directly to the carbon atom that contains the hydroxyl group. And this is an example. You can see one alkyl group, a second alkyl, and a third alkyl group. This compound is 1, 2, 3, and we have methyl attached to the second atom. So when we want to name it, it is 2-methyl-propan 2-ol. 2-methyl-propan 2-ol is a tertiary alkanol. Ethanol. We will use ethanol as example to explain the other properties, method of preparation, and uses of the other alkanols. Ethanol is commonly called alcohol. It has the general molecular formula C2H6O, and it can be represented as C2H5OH. And the structural formula is as shown. You can see, you show your carbon atom, 2 carbon linked to 5 hydrogen atoms, and then also linked to a hydroxyl group, which is the functional group. Industrial preparation of ethanol. Ethanol is prepared industrially by two processes. One is catalytic hydration of ethene, and the second is by fermentation. We take these processes one after the other. Catalytic hydration of ethene. Ethene is passed into concentrated tetrasulfuric acid at about 80 degrees Celsius and 10 atmosphere to form ethyl hydrogen tetrasulfate 6. Now, this ethyl hydrogen tetrasulfate 6 is hydrolyzed by boiling it with water. You can see the equation here, where the ethene is combining with H2SO4 to give ethyl hydrogen tetrasulfate 6. And then the ethyl hydrogen tetrasulfate 6 boiling with water to give you ethanol, and the tetrasulfate 6 acid is recovered back. So tetrasulfate 6 acid enters the equation, the process, and it comes out the same way. So it's the hydrating agent. Hydrating is adding water molecule to the ethene. After this, the product can undergo distillation so that the acid will be left behind, and the ethanol can be used as the product of the distillate. The second preparation of ethanol is by fermentation. Fermentation is the slow decomposition by microorganisms of large organic molecules such as starch to produce small molecules such as ethanol and carbon 4 oxide. So when we have large organic molecule like starch or any type of sugar, you add microorganisms like yeast. In the absence of oxygen, it will produce carbon 4 oxide, and ethanol is the product. They are the product of fermentation. Ethanol can be produced by fermentation using different foodstuffs, such as starchy foods such as cassava, rice, sorghum, millets. They can be used to produce ethanol. We can, excuse me. We can also use molasses. Molasses are thick syrupy liquids. We can use grapes, fruits, plantain, pineapple, apple, sugar cane, and honey. All these can be products through which ethanol can be gotten. Now we start from starchy food, using starchy food to produce ethanol. The starch, like corn or sorghum, they are crushed and pressure cooked to extract the starch granules. You can see this starch granules being extracted. Now, after that, malt is added. Malt is added at temperature of 50 to 60 degrees Celsius to the starch granules and left for about 1 hour. Malt is partially germinating barley. Barley that is germinating slowly is malt. Now, the enzyme, this malt contains the enzyme diastase, which converts starch to maltose. You can see the equation. This is the formula for starch. Starch is a polysaccharide, so we put N. So when the enzyme diastase acts on it in the presence of water, it forms maltose. This is the formula for maltose. This reaction is hydrolysis because water molecule is being added to the starch in the presence of the enzyme diastase. After that, yeast is added. Yeast is added at room temperature. Yeast contains two enzymes, maltase and zymase. Maltase converts maltose to glucose. Maltase converts maltose to glucose. You can see the equation, and it's still hydrolysis. Water molecule is added to the maltose and is being hydrolyzed to glucose. Finally, the enzyme zymase decomposes the glucose to ethanol and carbon 4 oxide. So the main product of fermentation is ethanol, while carbon 4 oxide is the byproduct. This is yeast that is added to bring about this complete fermentation. Another source of fermentation is from molasses or from cane sugar. Like I said, molasses remains after the crystallization of sugar cane. You can see sugar cane that after it's being crushed and the liquid extracted, we have molasses. Now, when we are doing fermentation by molasses, yeast is the only thing added. Yeast is added. Yeast contains two enzymes, invertase. Two enzymes, invertase and zymase. Invertase converts sucrose to ethanol to glucose and fructose. It's still hydrolysis, invertase, converts sucrose to glucose and fructose. Finally, the Zimase will convert both the glucose and the fructose to ethanol and carbon 4 oxide. These are the method of preparation of ethanol industrially. Physical properties of ethanol. Ethanol is a colorless volatile liquid with a characteristic smell and taste. Ethanol is a colorless liquid and is volatile. When you open it, it vaporizes into the atmosphere. Ethanol is very soluble in water in all proportion, and this is due to the presence of hydroxyl group. Ethanol has slightly high boiling point of 78 degrees Celsius. Now, the solubility of ethanol in water and its high boiling point is due to the presence of hydrogen bonding. It forms hydrogen bonding with water molecule. Chemical properties of ethanol. Ethanol have different chemical properties which include combustion, reaction with sodium and potassium, reaction with chlorides of phosphorus, oxidation, esterification, and hydration. We take these chemical properties one after the other. Combustion. Ethanol burns readily in oxygen with a pale blue flame to yield carbon 4 oxide and water or steam. So you can see the equation, ethanol plus oxygen producing CO2 plus water. So ethanol, because it can burn, it can be used as fuel. Ethanol reacts readily with sodium and potassium at room temperature to liberate hydrogen gas. When it's reacting with sodium, apart from liberating hydrogen gas, forms a compound that is called sodium ethoxide. Sodium ethoxide, you can see it. So ethanol reacts with sodium to form sodium ethoxide and liberate hydrogen. If it's potassium, it will form potassium ethoxide. Reaction with chlorides of phosphorus. Ethanol reacts very vigorously with phosphorus 5 chloride in cold, giving steamy fumes of hydrogen chloride and chloroethane vapor. So ethanol can react with phosphorus 5 chloride and also phosphorus 3 chloride. Ethanol reacts with oxidizing agent, that is oxidation. Ethanol reacts with oxidizing agents like sodium heptaoxodichromase or potassium acidified potassium tetraoxomanganese 7 to form ethene and to form ethanol and water. And then in complete oxidation, it forms ethanoic acid. This reaction is common to all primary alkanols. All primary alkanols are oxidized to alkanols and then to alkanoic acid. So ethanol is oxidized to ethanol and then ethanoic acid. If it's propanol, it will be oxidized to propanol and then propanoic acid. Now, secondary alkanols are oxidized to alkanones. So if I have propan-2-ol, it will be oxidized to propan-2-one. Propan-2-ol is oxidized to propan-2-one. While tertiary alkanols are not oxidized at all. So that is for oxidation. Esterification. Ethanol reacts reversibly with organic acid to yield ethyl esters. This process occurs in the presence of mineral acids like tetrasulfuric acid, which act as a catalyst. All alkanols react with alkanoic acid to form ester and water. The process is a reversible reaction, and the catalyst is H2SO4, and it needs to be heated in the presence of heat. So you can see ethanoic acid reacting with ethanol to produce ethyl ethanoate and water. So the alkanoic acid part counts first in writing the equation before the alkanol part will now be the second place, because sometimes they can give you other compounds. Maybe they may give you methanoic acid and ethanol. So the methanoic acid part should come first, then the ethanol part, so that it will be ethyl ethanoate. We call this part first ethyl ethanoate. That is the ester that is formed plus water. Dehydration. Ethanol can lose its water molecule in the presence of tetrasulfuric acid. Tetrasulfuric acid acts as the dehydrating agent. So alkanols like ethanol undergo dehydration in the presence of concentrated tetrasulfuric acid to yield ethene. The process is in two stages. First of all, the ethanol combines with the tetrasulfuric acid to yield ethyl hydrogen tetrasulfuric acid. The ethyl hydrogen tetrasulfuric acid is heated to about 280 degrees Celsius to yield ethene, and tetrasulfuric acid is recovered back. So tetrasulfuric acid is the dehydrating agent. Uses of ethanol. Ethanol has so many important uses, which includes as solvent. It's used as solvent to dissolve resins, varnishes, perfumes, dyes, drugs, flavoring extracts. Ethanol serves as raw materials for ethyl ester, ethoxyethane, trichloroethanol. Ethanol is used as fuel in racing cars and in rockets. Ethanol serves as antifreeze in automobile radiators. In some countries where their temperatures are very low, ethanol will help the water in the radiator not to freeze, because ethanol has a very low freezing point. Ethanol is present in alcoholic beverages such as beer, wine, and spirits. So you can see ethanol used as varnishes, used as fuel, and some used as alcoholic drinks. So that is uses of ethanol. Let us take some practical exercises using Examguide app. You can get this app from our website, examguide.com, or from Google Play Store. Now let's see how to go about it. You click on the question. This is WEAC, WASE. Now we have the objective and the theory. For quick, let's just take some questions from the objective part. Now, because we are dealing with chemistry, we select chemistry. You get to the year. You see, for this, we just select, you see different years, but we just select random. And then we select the topic of interest. Before you select the topic, you first of all unselect all, so that you can be able to scroll down. Now, our topic of interest, remember, is alkanols or alcohol. So we'll look for the topic of interest. So you click, you select the organic chemistry, and then you OK it. Now let's get started. So you can see we have different questions here. So the first question says, the products of fermentation of sugar are, from our learning, you know that the products of fermentation of sugar are ethanol and carbon 4 oxide. So option C is the right one. So you take another question. Let's take number 2. The solubility of ethanol in water is due to its, I explained it to you, it's not covalent nature, low or high boiling point is hydrogen bonding. Hydrogen bonding makes it very soluble. Now let's go a little further. Say the gas given off when ethanol reacts with sodium is, from understanding, is hydrogen. Hydrogen gas is given off when ethanol reacts with sodium. We take another one. The IUPAC name of this compound, we have Cl, we have CH2, we have another CH2 and OH. So we start counting from here. 1, 2, and Cl. So that is 2-chloroethanol. 2-chloroethanol, because there are 2 carbon atoms. So D is the right answer. Now we take our last question. This is our last question. Which of the following industrial process depends on the action of enzyme? Which of the following industrial processes depend on the action of enzyme? So we are going to take brewing of beer. Remember, that is fermentation. Fermentation depends on the action of enzymes. So you can practice as much as possible using our question. There are so many of them to help you to prepare for your external and internal examinations.